will now show how to express each step of the elimination as a matrix multiplication. So what we will be doing here is forming what we call the elimination matrices. And I will demonstrate this using the problems that we worked in the previous lecture where we demonstrated elimination. Our first matrix, the first A matrix that we worked on, I'll rewrite it here. Okay, that was our A matrix. Now, the first thing that we did here was we formed a new row 2. And row 2, in the first step of our elimination, became row 2 minus 2 times row 1. The goal here is to express this operation, row 2 becoming row 2 minus 2 row 1, with a matrix multiplication. The matrix that we're going to multiply A by on the left, we will call E21. And the reason we call it E21 is because it is the elimination matrix E that is eliminating the 2-1 position. This position right here, row 2, column 1, in the A matrix. Now remember, we're multiplying on the left. This will be my A matrix again. And the result here will be the result that we got from the first elimination step. In the first elimination step, our second row is the one that changed. And it changed to the following. Since this is E21 and we're only eliminating the 2-1 position, the third row is also not going to change. And now we have to figure out, what do we put in this E21 matrix to make this multiplication correct? Now, since our first row didn't change, the first row of E21 would be the first row of an identity matrix. Notice that as we perform the multiplication of this row into each column of A, we only get the element from the first row, and that's what forms the first row of our result, this row. Similarly, since the third row didn't change, we need row 3 from an elimination matrix, or from an identity matrix, 0, 0, 1. Notice here that this 1 in the 3, 3 position will always multiply in the third row of A. We won't take anything from the first or second row of A because of these zeros in the 3, 1 and 3, 2 positions. And so we will return the same third row as we have in A. Now, row 2 is the one that changed, and so we ask ourselves, okay, how did row 2 change? Well, it changed by taking 1 of row 2, right here, and subtracting from it 2 row 1s. The element of the elimination matrix that will multiply in the first row is here. Since we need negative 2 of row 1 from the A matrix, we put a negative 2 in this position. We need 1 row 2, so we put a 1 in this position. We didn't use row 3 in the formation of the new row 2, so we put a 0 here. Notice that the negative 2 will multiply in the first row, giving us negative 2 row 1s, and the 1 will multiply in the second row, giving us 1 row 2. And now, if you check, this elimination or this multiplication is correct. next step will be to form the matrix E31. E31 is the matrix that eliminates the 3-1 position. We'll put E31 here. E31 is not operating on A, it's operating on this matrix. And the result will be the result from our elimination after we did the elimination of the 3-1 position, which looks like this. In our elimination step, row 3 was transformed by taking row 3 minus 3 times row 1. So again, row 1 did not change. So in the first row of E31, we take the first row of an identity matrix. In this case, row 2 did not change either. So again, we take the second row of an identity matrix. And now we need to figure out what to put in the third row in order to make this multiplication correct. Now to form the new row 3, we had -3 row 1s. So we put our -3 here. Notice that this -3 will multiply in the first row of this matrix. We didn't use any row 2s. So we put a 0 here. The 0 will multiply across row 2. But we did use one row 3. So we put a 1 here. Okay, now we've formed E31. We have one more elimination matrix to find. The final matrix that we need to find is called E32. E32 is the matrix that represents the elimination of the 3-2 position. It will multiply the result of the previous elimination step and the result will be, now for this final step, the upper triangular matrix, which looked like this. Again, our first row didn't change, so we take the first row from our identity matrix. Our second row didn't change, so we take the second row from our identity matrix. Our third row did change. The third row changed with the following formula. Row 3 went to row 3 plus 2 row 2. We didn't use row 1 in this step, so we have a 0 in this position that will multiply through row 1. We needed 2 of row 2, so we put a 2 in this position that will multiply through row 2, and we used 1 row 3. So now we have our final elimination matrix E32. Now, we started out with an A matrix. The first thing that we did to that A matrix was we multiplied it by E21. We took that result and we multiplied it by E31. And then we took that result and we multiplied it by E32. And this result gave us U, the upper triangular matrix. Remembering from our properties of matrix multiplication that we do have an associative property, we can rewrite this multiplication like this. And the reason that we rewrite it like this is because now, if I take this piece here and multiply them all together, I get a matrix that I will call E, such that if I multiply that matrix times A, I get my upper triangular matrix U. Let's take a look at what that would be. So first I need E32. I'm going to multiply that by E31. Here's E31. And I need to multiply that by E21. First, I'll multiply these together. And then I'll multiply that result by E21. This is my matrix E. And let's verify that this worked. I'm going to repeat the matrix E here. And we'll multiply it by A. And let's see what we get. My first row isn't going to change because I have an identity row in the left here. The next element will be minus 2 plus 2 plus 0, which gives me a 0. In the second row, second column, I will have minus 4 plus 5 plus 0, which gives me 1. And in the second row, third column, I will have 2 minus 4 plus 0 minus 2. In the third row, first column, minus 7 plus 4 plus 3 gives me 0. In the third row, second column, I have minus 14 plus 10 plus 4, which gives me 0. And in the third row, third column, I have 7 minus 8 plus 2, which gives me 1. And we see that this is, in fact, the matrix U. Let's try this again using the second problem that we did in the last lecture. So in this case, we had an A matrix, 2, 1, and minus 3, 5, 2, and minus 6, 3, minus 1, and minus 4. My first elimination step, E21, transformed this matrix into the matrix 2, 1, minus 3, 0, minus 1, 3, 3, minus 1, minus 4. This pivot eliminated this position. We did this by forming a new row 2 that consisted of twice row 2 minus 5 times row 1. Our first row did not change, so we'll have an identity row. Our second row did change. We had minus 5, row 1, 2, row 2. We didn't use any row 3s, so we put a 0 there. And the third row didn't change, so we take row 3 of an identity matrix, and we have our E21. E31 transformed this matrix into the matrix 2, 1, minus 3, 0, minus 1, 3, 0, minus 5, and 1. And this elimination step was a result of row 3 going to twice row 3 minus 3 times row 1. So E31, again, row 1 did not change. Row Row 2 did not change. Row 3 was formed with -3 row 1s, 0 row 2s, and 2 row 3s. Our final elimination step, transform this matrix into U. Again, for this problem, U was equal to 2, 1, and -3, 0, -1, and 3, 0, 0, and -14. This step consisted of row 3 going to row 3 minus 5 times row 2. So we can form E32. Row 1 did not change. Row 2 did not change. Row 3 was formed with 0 row 1s, minus 5 row 2s, and 1 row 3. Our E31 matrix and the E21 matrix Okay, so now, again, the way that we performed this elimination, we started with the matrix A, and we first let E21 operate on A, or meaning that we multiplied the E21 matrix times A, which represents our first elimination step, and then the result was multiplied on the left by E31, and that result was then multiplied by E32. Now I want to mention at this point that it's important that we do these multiplications in the appropriate order, meaning E32 on the left, E31 next, E21 all operating on A, because that's the order in which we performed the elimination steps. While we can change the grouping, right, we have an associative property, we can't change the order. Recall that the matrix multiplication operation is not commutative. Okay, so I can again regroup. So we'll perform the operations. This order, and if I do that, I take this result first, here's E32, and I'm going to multiply that by E31. And if I do that, I get the result. this. Now I'll take that result and I'm going to multiply that result by E21. And that gives me my elimination matrix E. And again, this elimination matrix E is the matrix that encapsulates all the elimination steps. And I can show this by multiplying it on the left by my original matrix A and showing that the result is my upper triangular matrix U. So again, this is E, this will be A, and my result will be U. And now if I perform this multiplication, I do in fact get U. So we now have an equation E, the matrix that encapsulates all the elimination steps, times A, our original matrix, equals U, the upper triangular matrix.